Anyway, so I'm doing 1.4a. The first thing we're going to do in 1.4a is we're going to fill out this chart. But this chart has all the 6 trigonometric functions for the 4 quadrantal angles. So the first thing we're going to do is fill out everything for 0 degrees. And we're at 0 degrees. That means that we're over here on the coordinate plane. On the coordinate plane, we're somewhere over here on the x-axis. So I'll pick a point on the x-axis there. Let's say 1, 0. So in that case, x is 1, y 0, and r, the distance from the origin, is going to be 1. So remember, sine is y over r. So in this case, it's 0 over 1, which is 0. Cosine is x over r, which is 1 over 1, which is 1. And tangent is y over x, which is 0 over 1, which is going to give us 0. Now the cosecant, secant, and cotangent are going to be the opposite of those. So when we flip 0, we do r over y, that's 1 over 0, that's undefined. Okay, we have secant, that's going to be r over x, that's 1 over 1, that's 1, and the cotangent is going to be, what is it? Oh, 1 over 0, which is undefined. Now we do the same thing for 90 degrees. But at 90 degrees, we're not going to be at 1, 0 anymore. We're going to be at 0, 1. So 0, 1, 1. Okay, again, y over r. That's going to be 1 here. Y over r is sine. X over r is cosine. That's going to give us a 0. X over y is tangent. That's going to give us a 0. When we flip them, we get 1, undefined, and I messed up. Tangent's undefined because it's y over x. So this is undefined here, which gives us 0 there. 180, that's when we're going to be over here. So our point's going to be -1, 0. And r is, of course, 1 because r is always positive. So sine theta is going to be 0 again, y over r. X over r is cosine, that's -1. Y over x is tangent, that's 0. Cosecant is going to be the flip of sine, so flip 0, that's undefined because it's going to be 1 over 0. When we have flipped the -1, that's going to leave us with this -1 again. And cotangent, when we flip the tangent to 0, that's going to be undefined. Right? Now we go to 270. 270 is down here. That's going to be, have our points be x is 0, y is -1, and we're going to keep r being 1. It's easy to deal with ones. So 270. Y over r, -1. X over r, 0. Y over x, undefined. Flip the -1, gives me -1. Flip the 0 is undefined. And then flip the cotangent is, with it, flip the tangent is undefined. That's going to be x over y, that's going to be 0. So there's the chart of all the quadrantal angles and their formulas. You can find those out by putting them into a calculator. You just have to simply put in sine 0, cosine theta. The only thing you got to make sure is that we get mode first. When you get mode, you got to go make sure that you're in degree mode instead of radian mode. Okay, so here are 2 examples of problems that you're going to use the table to find. So cosine 90 plus 3 sine 270 degrees. Now we already know what the cosine of 90 and the sine of 270 are, so all you have to do is plug them in. We know that the cosine of 90 is 0. And we know that the cosine of the sine of 270, pardon me, is, what is it, -1. Okay? So when we replace them in there, you have 0 plus 3 times -1. 3 times -1 is, of course, -3. And 0 plus 3, -3, excuse me, is -3. And that's the answer. So it's just a matter of plugging things in. This one's a little bit harder over here because it has squareds. And whenever you see a secant squared 180, you can rewrite it like this. You can rewrite it as the secant of 180 degrees squared. Like that. The reason you can do that is because we don't want to write it like this. because when you write it like this, it's not clear whether you're squaring the 180 and then taking the secant, or if you're taking the secant of 180 and then squaring it. By putting the squared here, you're making that clear without having to write all these extra parentheses. So I'm going to write this out for these ones as well. This is 3 times the sine of 360 degrees squared plus cosine of 180 degrees. So secant of 180 we found out on the chart, which I'll pull up right now. Not -1. It's -1. -1 squared minus 3, the sine of 360 is 0, times 0 squared plus, and the cosine of 180 is -1. So -1 squared, remember when you square a negative number, you're going to get a positive number. So -1 squared is 1 minus 3 times 0 squared, 0 plus -1. So 1 minus 0 plus -1 is 0. So when we simplify this red expression up top, on the bottom, in the end, we get a 0. Before I show you how to do the next problem, let me bring up a page that has the reciprocal identities on it. You're probably going to want to copy those down in your notes. It's going to make doing these problems a little bit easier. Okay, so up here is the problem we're going to solve. We want to find the cosine of theta. If I know that the secant of theta is 5/3, which is something we didn't have too much trouble doing before, because all we had to do is flip the 3 and the 5. And the reason I'm showing this problem is because I want to show you that flipping the 3 and the 5 is actually an application of the reciprocal theories that we just put on the board. So cosine theta, if you look back at your notes, you should see that the cosine of theta is equal to 1 divided by secant theta. Okay, so now we just plug it in. So that means cosine theta is equal to 1 over 5/3. When we divide fractions, this bar just represents a division. So I'm going to rewrite that as the cosine theta equals 1 divided by 5/3. And I'm going to rewrite this 1 as its own fraction, 1 over 1. And if you remember back in elementary school, when you divide fractions, you flip and multiply. So cosine theta, and you only flip the second fraction, is 1 over 1 times 3 over 5, which equals 3/5, which is exactly what you would have gotten if you just would have flipped that from the get-go. Here's another application of the reciprocal identities. We want to find sine theta if cosecant of theta is -√12/2. So it's going to be a little bit more complicated now because we have the root in it. The first thing I want to do at all times is I want to simplify the radical. So I take the 12, and I know that 12 can be broken down into the square root of 4 times the square root of 3. And the reason I picked those two numbers is because I know that 4 has a square root. So I want to pick a number that has a square root that divides into 12, and 4 accomplishes that goal for me. So if I take the square root of the 4, I get a 2. So I have 2 times the square root of 3. So now I can change this out for the square root of 12. It's right there. That's what I'll do. This means that the cosecant of theta equals -2√3/2. That's good for me because these 2's cancel out. And I know that this equals negative square root of 3. Okay? Now I use a reciprocal identity. If I want to find the sine of theta, then I have to put the √3 under a fraction. But I can't leave it like that because I have to rationalize the denominator. You're not allowed to have a radical on the bottom. So I rationalize it by multiplying the top and bottom of the fraction by the square root. When I do that, I get 1 times √3, which is just √3, over √3 times √3, which is 3, and that's my sine. And I'm done. There'll be problems like that on your work, and there'll be problems like that on the test.